Good morning, algebra people. Welcome to another wonderful day of mathematics with virtual Mr. Coach. I am sorry I cannot be here today. Hopefully today is my last day of jury duty. But we're going to explore the wonderful world of given statement reason. This is really another introduction to proofs. We're kind of beginning to walk into that world. And a proof is really just a logical argument that shows that a statement is true. So much like the lawyers that are surrounding me in jury duty, they cannot walk into a courtroom and be like, Your Honor, my client is innocent because he's innocent. They have got to be able to prove what they're saying is true to get their client innocent. So we're a two-column proof. It's numbered statements and their corresponding reasons that show an argument is in a logical order. So there's going to be a flow to how these guys work, and you guys are going to be able to see that as we get into them more. But there is not an exact answer for these guys. So some valid reasons that you guys will see for a proof may be theorems. Okay? I gave you guys a whole sheet that was nothing but theorems, postulates, definitions. Oh no. Or even properties. So that sheet you guys have, your little cheat sheet, is chock full of pretty much every theorem, postulate, definition, property that you guys are going to use. Okay? When we begin our proofs, the first thing we're going to write is always our given. Okay, so you should at least get part of it correct. And the final thing you write is going to be our prove statement. Okay, it's basically, what did we prove, and then logically did we make our way down to it. Just some helpful hints here. Postulates are rules that are accepted without proof. Rules that are proved are called theorems. Postulates and theorems are often written in conditional form, which is our if-then statement. And then unlike the converse of a definition, so like our congruence definition, which states that two things are equal or congruent, we can intertwine them. The converse of a postulate or a theorem cannot automatically assume to be true. So some examples we got today. So it says, draw a conclusion based on the given diagram or information. So it told us that M is the midpoint. So there's our midpoint. So because M is our midpoint, the next logical conclusion would be that segment XM is congruent to segment MY. Because a midpoint bisects our statement, making those two congruent. And that would be the definition of midpoint. You guys are going to see, again, it's just practice, it's repetition. On your homework tonight, okay, it's one page, and I've got a bunch of like random blanks mixed. So you guys are going to try to figure out, well, what's really happening, and then try to deduct with each other what's going on. Okay, so they gave us that BD bisects, which means cuts in half, ABC. So we can then say, because it's cut in half, much like our midpoint, we know that angle, can't text here, we know angle ABD is congruent to angle DBC. So what's that saying is, because BD bisects that angle, it cuts it equally in half. And then these little halo tick marks also show congruence, much like the tick marks on our lines did above it. And that reason is the definition of an angle bisector. Let's do some more. Okay. So we've got 1 and 2. So we know that number 1 and 2 are vertical angles. So we can't say they're congruent yet because we got to prove it. Angle 1 and angle 2 are vertical. Okay, and the reason we can say that is the definition of vertical angles. And because they are vertical, that means my two angles are congruent. Because that is our vertical angles theorem. So again, guys, we're just going to practice. I've got a little fun little puzzle for you guys to do. It's just going to start to become second nature. So when I first started teaching this a couple years ago, the last time I saw proofs was in college. And the last time I taught proofs was my first year of teaching when I was helping out our geometry teacher. And then over the last 3 years, I've really been able to reaffirm what I'm doing, understanding how it works and how we can make it work. So our given, L is perpendicular to M. Remember that little upside down T? That's my perpendicular side. Okay. So because they're perpendicular, we know angle 1 is a right angle. And that is the definition of perpendicular lines. And then because it's a right angle, we know the measure of angle 1 is 90 degrees. And that's because that's our definition of right angle. So you guys can see that there's kind of a little bit of flow to it. The awesome thing about proofs are they're going to kind of help you as you progress through it. And they're not just going to leave this whole like open-ended thing where what are we actually proving, trying to figure that out. You're going to see a flow, and your proof statement is going to be an obvious, well, dang, this is what I'm working to. This is what I'm trying to get to. So that's going to make my life a little bit easier. It says, my given, angle 1 and angle 2 are supplementary. Well, that's easy because that means the measure of 1 and the measure of 2 is equal to 180 degrees. And that is the definition of supplementary. You guys are going to see that it's a lot of definitions, and it's making your life a lot easier. So there's a couple of ways you can go here. We don't know if BD is bisecting, so we're not going to use that whole my two angles are congruent thing. But what I do know is that that big angle is 90 degrees. And because my larger angle is 90 degrees, we can kind of get to where we need to. So I know that this larger angle is composed of two smaller angles. I've got angle ABD and angle CBD. So you guys can kind of see that. And we know that the sum of those two angles is 90 degrees because it told us. So if I erase those lines we draw to help us see it, I know that that is a 90-degree symbol. And because of that, we're going to say that's our given. They didn't really give us any actual leg to start with. But again, when you start doing your actual proofs, they're going to tell you, here's your given, here's what I want you to end with. Try to find the flow to the bottom. So we can conclude based off of that ABD and CBD are complementary. And that don't just mean they're friendly angles. Okay, and because of that, because we know that is because of the definition of complementary angles. So again, your homework, guys, it's fill in the blank. So I'm kind of helping you guys start to understand what it means to flow through these proofs. We're going to go really hard on them when we get back from the weekend. We're going to really start to play around with our proofs and try to figure out what's going on. You guys have an awesome day, and hopefully I get to see you on Thursday.